Hello and welcome to Space here from Rome. We've come to Italy in order to take a close look at something we all take for granted. Earth, the largest rocky planet in our solar system. It really is the most extraordinary place. So let's take a step back now and have a look at Earth as a planet. This is it, 149.6 million kilometres from the Sun, about 4.5 billion years old, the only planet we know capable of supporting life as we know it. It's not like anything else in the solar system.
Planet Earth is quite a particular planet. I mean, you see it here behind me. It's a fascinating planet. We have 70% of water. We have land masses which are actually moving over time. We have an atmosphere which is rich in oxygen, in nitrogen, in water vapor. All these are necessities in order to really have life on a planet like this.
In Rome, you see constant reminders of how important liquid water is to our planet. Unlike Mars or Venus, Earth has the right temperature and correct atmospheric pressure for water to flow on its surface. And it also flows underground. Here below the Villa Medici lies the only aqueduct that has been in constant use since Roman times.
Here we are in the Acqua Virgo aqueduct. This is a section of one of the most important aqueducts supplying Rome, dating from the 1st century BC.
The water that flows on the surface is essential to life, and it also plays a vital role in the geology of our planet far deeper underground.
Water is a very important component in the formation of magma and an important component in all the processes to form rocks, be they volcanic or metamorphic or sedimentary. So for that reason, it has been really important in the evolution of our planet Earth.
They call Rome the Eternal City, and its ancient monuments may look like they've been there forever. Yet the building materials the Romans used are materials that once flowed as molten rock beneath the Earth's crust.
Rome is to a great extent constructed from volcanic rocks. The famous 7 hills are made from this kind of rock. This in particular is called tuffo leonato, thanks to its colour, which looks similar to the colour of a lion's mane.
Everything we've used to forge our civilizations comes from the earth below our feet. And if you look at it closely, just 3 key ingredients dominate.
Our planet is mostly made up from iron, silicates and oxygen. They make up 3/4 of the material that we find on Earth.
Our planet is 12,742 kilometres in diameter, a little bigger than Venus and twice the size of Mars. So much of our knowledge of Earth is very recent. When these globes at the Italian National Institute for Astrophysics were made 500 years ago, some were still debating whether the Sun orbited around the Earth.
All the comprehension about how the solar system works is obviously quite recent. We're talking about Galileo and Newton. Obviously, this gave us a completely different point of view. In ancient times, we thought the Earth was at the center of the universe, and now we know the Sun is at the center of a planetary system, which is at the outskirts of a galaxy, which in turn is at the outskirts of a remote part of the universe. This immediately gave us a different vision of where we are and who we are.
Our vision of who we are and where we are gets clearer every day thanks to space technology. ESA has built 15 Earth observation satellites feeding data to this centre near Rome. They offer a global view on everything from soil moisture to gravity, and they've even spotted a subtle shift in the magnetic poles.
We're entering the room from where our ground station network is being managed. And what you see here are our ground stations in Kiruna in Sweden, in Matera in southern Italy, and down here in Svalbard in Norway. At the moment, the magnetic pole is migrating with about 40 kilometers per year, possibly taking us to a polar inversion. Long overdue, we haven't had one for 700,000 years, and the poles may flip in the coming few thousands of years.
Even the most remote areas of our planet can be measured with unprecedented accuracy from space. This satellite, Cryosat, launched in 2010, has now shown the true impact of our warming climate on the polar regions.
We had the warmest pole Arctic summer last year, and we are losing polar ice rapidly. At the moment, we lose almost 125 cubic kilometers of ice in Antarctica every year, and 3 times as much in Greenland.
Earth is a very dynamic planet, and many of the changes we see are part of natural cycles. Yet it's become clear that mankind's greenhouse gas emissions are altering the climate.
We changed the planet, it's a fact. The question is, how can we best understand what happens and possibly avoid the biggest damage in order to not destroy it completely.
Earth as a planet will continue to evolve and change over billions of years. The issue is what role we play in that future. And now to our regular mini-series Legends of Space. Throughout 2017, we're celebrating 60 years since Sputnik by looking at some of the greatest names in spaceflight. And this month, we've chosen NASA's Space Shuttle, which made its maiden flight in April 1981. ESA astronaut Claude Nicollier flew on the shuttle 4 times and tells us what it was like.
T-minus 10, 9, 8, 7, 6, 5.
When you looked at it, you were thinking, wow, is that really going to work?
1, 0, and liftoff.
It took about 8.5 minutes to get to orbit. It was quite a ride, especially the first stage with a lot of shaking. Then separation of the boosters with huge flames. Every second you were adding 30 meters per second to your velocity, this for 1.5 minutes to reach the 28,000 kilometers an hour velocity. And then main engine cut off, and then you go from 3G to 0G in about 1.5 seconds. And that was quite impressive, especially the very first time it happens to you. The intervention capability of the shuttle was remarkable. You could rendezvous with the satellite, pick them up with a robot arm, put them in a payload bay, bring them down to Earth. In order to re-enter the atmosphere on this elliptical orbit, we had to take the proper orientation, which was 40 degrees nose up. And right after we had gone through Mach 1, the commander was taking manual control, and he flew entirely manually. Great. For a pilot, it was a dream, a real dream.
And Commander Mark Polanski rotating the nose gear down to the deck.
Loud and clear, Louie. How are you?
Well, that's all we have time for in this programme. We'll be back next month, and in the meantime, you can keep up to date with other news from the universe on our space blog on Euronews.com.